Welcome back, dear students. Let me discuss about the corrosion of the metals. So, corrosion is basically the destruction of the metal by the chemical action of the metal with respect to exposed to air and moisture present in the environment. So, it is actually the chemical destruction or the destruction of a metal by a chemical reaction by the action of oxygen and moisture present in the environment. The actual chemical reaction involved in the corrosion of the metal depends on the nature how which the metal is exposed to the environment. In most cases, it may be a direct chemical reaction by exposure to the atmospheric that is gases, or it may be an electrochemical destruction of the metal in the presence of oxygen or water. So usually it is speculated that the corrosion of the metal is an electrochemical reaction. Therefore, it is seen that corrosion can be defined as the electrochemical destruction of a metal by its exposure to air and moisture of the environment. And this electrochemical destruction is accelerated by the presence of acid environment, but it is diminished by the presence of the alkali. Again, the corrosion is defined as the destruction of the metal by the chemical reaction with the oxygen, air or various gases and moisture present in the environment, and it is purely an electrochemical reaction or it may be purely a chemical reaction. Corrosion, depending on the nature of the destruction of the metal, depending on the nature of the exposure destruction, that is, we can classify corrosion of two types. One is corrosion of two types. One is dry corrosion. That is the corrosion of the metal by the exposure to various gases like halogen, oxygen, hydrogen sulfide, sulfur dioxide, etc. in the absence of moisture. In the absence of the moisture, that is called a dry corrosion. Is a direct attack of the metal, so that the metal is converted to sulfide, or metal is sulfide converted to oxide, or metal is converted to carbonate, or the metal is converted to sulfate, etc. The tarnishing of silver, blackening of lead sulfate, that is green coating on bronze and copper, very degrees. All these are examples of dry corrosion. It actually involves the direct attack of the metal surface by the various gases present in the atmosphere. This dry corrosion is actually purely chemical action. It is a chemical destruction. Chemical destruction. Example, and it is a dry corrosion. Why it is called dry corrosion? The dry corrosion is that corrosion of the metal surface by the direct action of various gases present in the environment in the absence of moisture, and that is why it is called dry corrosion. Example, tarnishing of silver. That is the position of a green scale. Green scale on copper or bronze. That is build degrees, and the tarnishing of that is silver due to silver oxide, AgO or AgS, Ag2S. This is a direct attack of silver by oxygen or hydrogen sulfide. This is a direct attack of copper or bronze with the carbon dioxide, and some other gas, sulfur dioxide, will attack on the metal surface so that the metal get tarnished. That is an example. So the general reaction here is M plus O2. Okay, Mn plus M2M plus O2 N by 2 O2 giving the dry corrosion is given like this 2Mn plus. Okay, that is there N by 2. Oxide is about balancing only Mn plus Mn plus NON O2 minus. This is an example of but in most cases what is actually happening is that the metal is converted to a metal oxide. So an example of the tarnishing of silver is the best example. So corrosion is of two types. One is a dry corrosion in which it is a direct chemical action of the metal by the action of various gases like oxygen, sulfur dioxide, H2 is present in the atmosphere or environment. And here the reaction is that metal in most cases are converted to sulfide or oxide. The reaction is like that. Okay, 2M plus half N by 2 O2 giving Mn plus NO2 minus. Example is the tarnishing of silver and blackening of silver and formation of green scale on the surface of bronze or bronze or that is okay. All these are examples, and here the reaction takes place in the absence of the moisture, hence we have to ensure that this takes place in the absence of air, therefore it is called dry corrosion. And second type of corrosion is wet corrosion. Second is wet corrosion. As the name implies, this takes place in the presence of moisture. This is actually the electrochemical attack. It is actually the electrochemical attack of the metal by the gases present in the atmosphere in the presence of moisture. And the moisture, water acting as the electrolyte and various dissolved gases. The water along with the dissolved gases present in the water acting as electrolyte. Okay, that is why this kind of reaction is called wet corrosion, and is called mechanism is electrochemical destruction of the metal. Okay, and the electrochemical metal can be represented like this. So this is a destruction of the metal, the electrochemical destruction of the metal in the presence of moisture and air is called wet corrosion. So here it can be represented as metal is converted to Mn plus an electron, and the metal dissolves. Metal dissolves in water. Dissolved into the solution state. This Mn2 plus get dissolves in the solution. And again it is converted to forms oxide compound. Complex oxide compounds by oxidation. Okay, it forms oxide compound like oxides by the oxidation with air by O2. It's converted to form oxide compound by oxidation. So the metal first attacks by the moisture present in the water by electrochemical process. So it undergo oxidation. The metal undergo oxidation on the one side. So here actually take place. I will come to the mechanism here. The wet oxidation, there is the metal surface. The metal surface actually is divided into two parts. The metal surface itself contains one end acting as the anode area, while the other end acting as the cathode area. In between this, there is a solution of electrolyte containing water dissolved some gases. At the anode area, the metal undergo oxidation, thereby undergo destruction. And the dissolved ion of the metal dissolves in the solution water, and it is further oxidized by the air present in the atmosphere to form the complicated oxide compound, that is actually rust. Okay. While the other part, cathode part is actually protected as such. So the anode part undergo destruction. Okay, whatever may be the situation, suppose we are giving a condition for an anode and cathode cell to be set up in a metallic surface in the presence of moisture and oxygen, it will surely undergo corrosion by the electrochemical destruction. Then we have to explain the mechanism of electrochemical theory of corrosion using rusting of iron. Electrochemical theory of corrosion with respect to rusting of iron. With respect to rusting of iron. It's very important. I hope that this may be asked for a short essay in your examination. Okay. Let us explain the rusting mechanism of iron article based on the electrochemical theory. How the rusting of iron, the corrosion of the iron material, the corrosion, that is a complicated oxide is formed on the iron surface. A coating of oxide, iron oxide is formed on the iron material, iron article when exposed to air and moisture, and that is called rusting. The complicated hydrated oxide of the iron, hydrated oxide is Fe2O3 XH2. This complicated oxide is called rust. It's a brittle material, brown brittle material, and when such a material is formed on the surface, we said the iron undergo rusting. How? We have to explain. That is the electrochemical theory. Okay. According to the electrochemical theory, you have to remember the corrosion of the metal is basically an electrochemical action. So, electrochemical action. Example, the rusting of iron. Rusting of iron. That is, here the rusting of iron takes place. Say it takes place in the presence of air and the moisture. The presence of the air and the moisture containing little carbon dioxide. Okay, you know that air always contains little carbon dioxide, and the carbon dioxide dissolves in the water forming carbonic acid. So it is assumed that the rusting of the iron takes place in the presence of air and moisture and carbon dioxide, because the carbon dioxide dissolves in the water forming carbonic acid. Here, consider the iron article. Consider an iron article exposed to air and the moisture. The one part of the iron, one article, one spot of the iron article which is in contact with the water. Okay, suppose we have an iron article. That one spot of the iron article which is in contact with the water, okay, undergo oxidation, and it behaves as an anode. That is the first situation. You know that? That is, the water contains carbonic acid due to the dissolution of the carbon dioxide. Or water contains dissolved CO2 in the form of H2CO3. Okay, which furnishes H plus ion. So the dissolved carbon dioxide dissolved or H2CO3 contained water acting as an electrolyte. This water containing H2CO3 acting as an electrolyte. So that spot of the iron material, that spot of the iron material in contact with the water which is acting as electrolyte, acting as anode, and therefore therefore undergo oxidation. Undergo oxidation, that is iron undergo oxidation in the presence of water. Okay, giving Fe2 plus 2 electron. This is the first reaction. This is the first reaction, that is the oxidation. The next is the dissolved, the iron oxide, ferrous iron that produce get dissolves in the water. Get dissolves in the water. While the electron liberated pass through the metal body, iron body. Okay, that situation I will draw this picture. This is our material. This is a small particle of iron. So that it contains some water here. It contains some water here. Okay, do it like this. Some distortion is there, so that water is held here like this. H2. Okay, that is. So that here is oxygen. It undergo oxidation. Here it acting as the anode undergo oxidation, so that Fe2 plus dissolved into it. Fe2 plus dissolves into it, while the electron is liberated here, and the electron moves through this side. And the electron that reaches near the air. Okay, the electron that reaches near that spot of the region, that spot of the ion particle will contain air, in which the electron reduces oxygen. The electron reduces oxygen in the presence of water. Okay, the electron or oxygen get reduced in the presence of water, forming. What happens is that, okay, sorry, the presence of H plus ion there. Okay, here it furnishes the water contain H plus ion. The water contain H plus ion here. We go to the okay, H2CO2 dissolved in it or CO2 dissolved in it. So in the presence of the oxygen gets reduced to water, the presence of H plus by the electron to form water molecule. This is a reduction. So again I want to say that consider an ion particle when exposed to air and water, that region or that spot of the ion particle which contain water undergo oxidation, so that iron is converted to oxide ion. So for the ferrous ion, undergo oxidation to ferrous ion first, and the ferrous ion dissolves in the water, while the electron goes through the body of the material and reaches that region of the ion particle in which it is exposed to air and water. At that region, the oxygen of the air undergo reduction in the presence of H plus ion present in the water. Okay, that is the exposed part, that part of the ion which is exposed to air undergo reduction and is oscillated by the H plus ion, small amount of water present there, H plus ion, to form oxygen is reduced in the presence of H plus ion to water molecule, that is reduction. Thus it forms a cell. Okay, it can be balanced like this, that is 2 plus 4 electron for 4 H plus, giving 4,2H2O liquid, and this equation will become 2Fe2 plus, giving 2Fe2 plus. So this is the oxidation, this is the anode spot, this is the cathode spot. What you have to stress, the important point here is that part of the ion which is in contact with the water acting as that, so it undergo oxidation. So oxidation is the destruction, the corrosion is initiated by the oxidation of metal, the presence of water, that is Fe giving Fe2 plus, and Fe2 plus dissolves in the water, causes solution, while electron goes the body of the material iron article and it reaches that portion which contain oxygen, and the oxygen is reduced to water molecule in the presence of H plus ion present in the water to form water molecule. That is the reduction. So oxygen is reduced to water in the presence of hydrogen ion present in the water there. So that region which is exposed to air is acting as the cathode. So the total cell reaction is that. The total cell reaction is that 2Fe plus O2 gas plus 4H plus giving 2Fe 2 plus 4Fe2 plus 2H2O liquid. This is a total cell reaction. So the total cell reaction is that ferrous is converted to, or iron is converted to ferrous ion. The presence of oxygen and the hydrogen ion present in the water molecule. Then finally, that is the ferrous ion move through the water. The ferrous ion produced moves through the water on the surface. Okay. That is ferrous ion comes to the surface of the water and dissolves in the water present in the surface, and it undergo slow oxidation by the atmospheric oxygen there. So it is further subject to oxidation by atmospheric oxygen. Okay, gradually get oxidized to ferric ion actually. That is the situation. So that is the situation. The ferrous ion get dissolved in the water and it floats on this water, and during that time ferrous ion is gradually oxidized by water, the presence of water, like this. That is Fe2 plus 4Fe2 plus oxygen 3O2 plus 4H2. Okay, 4H2O giving 2Fe2O3 is converted to 2Fe2O3 plus 8H plus. This is the complicated equation. That is, so during the course of the time, as the ferrous ion floats on the water's surface, present the water, it gradually undergo oxidation by the atmospheric oxygen, okay, in the presence of water, and is converted to ferric oxide, like this, plus hydrogen ion. And this ferric oxide reacts with the water molecule to form Fe2O3XH2O. Okay, they will combine with the infinite number of water molecules to form hydrated ferric oxide, that is a brittle brown layer on the surface, that is called rust. So that's the mechanism. Okay, I hope that you understand. You understand that I have explained? That is the iron article considered to be, okay, it contains dissolved, that is water containing dissolved carbon dioxide, that is H2CO3 acting as electrolyte, and the air, it is exposed to air also. That is, this iron particle has a one spot anode while other spot cathode. What do you think? That spot of the iron article which is contact with the water acting as the anode, therefore iron article undergo oxidation to ferrous ion, and the ferrous ion dissolves in the water, goes in the solution. While electron goes through the body of the material, the article, and reaches that part of the ion which is exposed to air, contact with air. There it undergo reduction. Okay, the electron get reduced, the oxygen get reduces to water molecule in the presence of, that is oxidized by H plus ion. The presence of H plus ion, this electron reduces oxygen to water molecule. That is a reduction. The overall reaction is the oxidation of ferrous in the presence of oxygen and ferrous H plus ion, oxidation of iron by oxygen, the presence of ferrous, the hydrogen ion, to form ferrous ion and water molecule. And the ferrous ion dissolved in the water floats there, and it gradually undergo oxidation, so as it is present surface, and is oxidized to by the atmospheric oxide, the presence of water to ferric oxide and hydrogen atom. This ferric oxide then combines with the water molecule to form Fe2O3 XH2O, that is the rest. That is formed here. Actually, it is formed in the junction. Fe2O3 is produced here. Okay. Then we have to explain how rusting of or prevention it can be avoided. What are the important method for the elimination of rust corrosion? One, there are various methods for elimination of corrosion. One is barrier protection. Barrier protection. Elimination of corrosion of the metal. One is barrier protection, that is, metal surface is coated with a protective coating like a paint, varnishes, okay, or the more corrosion resistant metal like a nickel, chromium, etc. That is the one method. So, surface of metal is coated with paint by it is paints, varnishes, okay, enamel, or by coating metal like nickel or chromium, which are corrosion resistant metal. Thin coating of metal like a nickel or chromium is coated on the surface, or paint, varnish, enamel are. This is called barrier protection, because we are simply protecting the surface of the metal by such a coating. Hence, it is called barrier protection. The next is sacrificial protection. Sacrificial protection. Here, the metal is protected. The metal is protected by coating. By covering its surface, by coating its surface with a thin layer of another easily oxidizable metal like zinc or aluminium, magnesium, etc. A metal like zinc, magnesium or aluminium is coated on the metal surface to be protected. Example, the iron material, the iron surface. So the iron articles is coated with the zinc, that is usually on the surface, that is called a galvanization. So iron pipes can be protected from corrosion. Corroding of iron pipe can be prevented by galvanization, by coating it with the zinc. That is called galvanization. The process of preventing corrosion of the iron article by adding a coating of zinc on it is called galvanization. That is an example of a sacrificial protection. Here, by it is called sacrificial protection. This metal, zinc, magnesium, aluminum, etc., are easily oxidizable metal. So they undergo oxidation. The easily oxidizable zinc, magnesium, aluminum, etc., they present on the surface undergo oxidation and undergo corrosion, and thus protect the metal present inside. That is a sacrifice. So instead of by protecting the metal present inside, okay, by itself undergoing corrosion, is called sacrificial protection. When we are coating the surface of iron article, the zinc present in the surface undergo oxidation because they are easily oxidized, and thereby it get distracted, and that iron article are protected. So as long as zinc coating is there, the iron articles are prevented from corrosion. So that is called a sacrificial protection because it is sacrifice. Okay. Instead of the iron article, this article undergo oxidation because they are easily oxidizable and protected the inside iron article. And this can be protected by another method, that is cathodic protection. Cathodic. That is, instead of coating this metal, the iron article is connected directly or through a wire to easily oxidizable metal like aluminium, zinc, magnesium, etc. Aluminium, magnesium or zinc strip, form of strip, is connected to a wire. This is the iron article. This is iron article. This is to be protected. This is to be protected. Therefore, it is connected through a wire to another aluminium strip or magnesium strip, magnesium or zinc strip, so that this acting as an electrochemical cell. Here the magnesium undergo oxidation, thereby it undergo corrosion, while this part acting as the cathode and it always get protected from corrosion. Hence it is called cathodic protection. So in this case, the metal to be protected, that is the iron, is acting as a cathode and thereby it is prevented from protection, because the other metal connected directly through it by a wire, that is magnesium, undergo oxidation acting as the anode, thereby this is protected and this is called cathodic protection. Here the metal to be protected is converted to is allowed to acting as a cathode by connecting it with an easily oxidable metal like aluminium, magnesium or zinc, and this way of protection therefore is called a cathodic protection. Okay, same mechanism. Here the metal is not coated, it is directly connected to the metal iron, so that the metal acting as a cathode, the iron article acting as cathode, while that metal connected, that is magnesium acting as anode. So therefore, magnesium or iron, aluminium undergo oxidation as it is oxidizable, while the other part of the iron acting as a cathode, it undergo protection. That is prevented from corrosion. It will prevent it from corrosion. Thus, since it is acting as the cathode, it is always prevented from corrosion. That is called cathodic protection. This is an electrochemical action. And finally, 4. By the anti-rust solution, by coating anti-rust, by using anti-rust solution. Certain alkaline solution of alkaline phosphate solution and alkaline chromate solution. Alkaline chromate. Certain alkaline phosphate and alkaline chromate solution, when coated on iron article, acting as a very powerful anti-rusting material. Okay, they are very powerful anti-rusting material because they can form a protective layer on the surface of such material. The radiators of the automobiles, internal parts and particles are protected like this. The radiators of the automobile car can be protected by coating as alkaline chromate or alkaline phosphate solution. They are called anti-rust solution. Okay, that's all. I hope that cathodic protection. This is the metal iron article to be protected from corrosion. So it is connected to a magnesium ribbon strip, Mg strip. So this magnesium, since it is also undergo oxidation, Mg2+, undergo oxidation. Okay, by the electron reaches here, so it can reduce as such, though it is acting as the cathode. So protected from corrosion, while it undergo corrosion, corroded. As long as magnesium strip is there, a small amount of magnesium strip is attached to this iron article. This iron article always acting as the cathode and is prevented from corrosion. That is the principle employed. So what the thing is that we have to replace the magnesium ribbon as time at a instant or in interval time. So at the substitute, that is replace the magnesium ion as it get consumed. And you know that the railway track, the iron articles, rail bridge, rails are protected by connecting it to this magnesium strip. You can see. That's all. This is a picture. This is a picture you can see. Iron pipe. This is a magnesium strip. It undergo oxidation and air electron reach there. It is protected as cathode. It is acting as a cathode and protected. This is called cathodic protection. Okay, hope that you have followed me. So I am winding up the class. Thank you very much. So with this, and again I want to tell you that I already discussed the hydrogen oxygen fuel cell in one of my lectures. So you please watch that video. The application is, that is the construction, the principle of hydrogen oxygen fuel cell, its working principle is also very important. Okay. That is basically a galvanic cell, but it's an electrochemical galvanic cell. There is the combustion, the heat of combustion is okay. The decrease in free energy or the redox reaction is not converted to the electrical energy, but is also not converted to heat energy. That is the combustion of hydrogen. The combustion, heat energy, the combustion, chemical energy, the combustion of the hydrogen oxygen reaction is not converted to heat energy, instead it is converted to electrical energy. So a galvanic cell is that cell in which the chemical energy of the combustion is not converted to heat energy, instead is converted directly into electrical energy, that is a fuel cell. A fuel cell is that cell in which the decrease in free energy, the combustion is directly converted to electrical energy. That mechanism is brought in such a cell, the hydroxygen fuel cell, using a perforated platinum electrode there. And the combustion of hydrogen or oxygen is carried out in a special manner so that the chemical energy is converted to electric energy and not to heat energy. So that aspect, that's my video class. Okay, thank you very much. Okay, with this, the electrochemistry part 2 is also finished. So you have to work out problem on referring your textbook or any other standard books. So do work out as many problems as you can. Okay. So we have finished the electrochemistry chapter 1, part 1, the electrolytic conductance, and the electrochemistry part 2, that EMF. So next class, we have to pass on to discuss the ionic equilibrium. Okay, thank you very much.